everybody. Here we are, 6.3, domain and range. First, a couple of definitions. So domain is all possible values for the independent variable, usually x, let's say, and let me make this a little bit bigger for you. So all of the things that x can be, basically. And here, maybe if I just copy this, can I do that? The range is going to be all possible values for the dependent variable y. So we're just trying to determine what is the range. And if you did the pet house project with me in grade 9, often we were restricting the domain and range to make our line kind of longer or shorter. So we're determining what are all the possible values for our x's and what are all the possible values for our y's. And often we talk in terms of real numbers. So what is a real number? And yes, I mean, its counterpart is the imaginary number, but a real number is all numbers, including, let's say, integers, let's say rational numbers. That's numbers that can be written as a ratio of two numbers or as a fraction, and irrational numbers. All of the numbers we're dealing with in Math 10 are real numbers. So this might seem a little irrelevant, but here we are. And integers are our positive and negative counting numbers. Whole numbers are positive counting numbers. And so, yes, basically not imaginary numbers or not, something like the square root of negative 25, not something like that. Okay, I'm going to erase that. So let's start kind of playing around with it. Let's start finding the domain and range. You'll notice maybe that I had this domain and range as my words of the day the last couple of weeks, but I don't know if you noticed. So let's read a little bit of this part that I put here from the textbook, and we're going to need to be able to figure out and express a domain and range in words. We're going to need to be able to express it as a number line. We'll need to be able to express it as interval notation and as set notation. And actually, there's another way. We'll need to be able to show it as a list as well. Let me write that down. I don't this highlight very well. We'll need to be able to show it as well as a list. But that's only for discrete data. And we'll see that kind of play out in our last question. So here we have a line. It exists on the x and y axis. It seems to go in, if we're talking about the x's, it seems to go from right here, -6, to all the way to here, to +3. And you'll notice right here we have a colored in dot. That means it includes. And here we have a not colored in dot, which means does not include. And you might remember that from Math 9 in our inequalities. So here's how we would describe this domain in words. So this is all real numbers between -6 and +3. It includes -6, but does not include +3. Here they express this on a number line. This shows that it includes -6 and goes to 3, but does not include it. You might be able to see there's a not kind of colored in circle right there. As interval notation, here you have the lower value on the left, the upper value on the right, and you'll notice two sets of brackets. You notice this square bracket and this round one. And the round one means does not reach. And the square bracket means that it reaches. Okay, so it reaches -6 and goes to 3, but does not quite reach 3. And as set notation, a set is just kind of like a group of numbers. This, we use these squiggly brackets. That kind of denotes a set. And then we have an X. There's this line. This kind of just means such that. So the X values are such that they are greater than or equal to -6 and less than 3, but not equal to 3. And this right here shows that X includes all real numbers. This E is a Greek letter. It's called epsilon, and it means is an element of. So we're saying that X is an element of all real numbers. Well, and I should tell you, the other math teachers say, often they tell the kids, you're not going to like this, but here we are. And really kind of what's the most important thing that they really want you to know and focus on when you're getting into later grades is to be able to do this part in between. Having the, X is such that, and including that it's an element of is important, but this is the kind of main idea that they really want you to get. And for the same is true of range, but now we're talking about all of our y values. So instead of talking about those x's, we are now talking about these values right here. It goes from -4, but does not include it, and goes all the way up to, looks like +5, and does include it. So all real numbers between -4 and 5, not including -4, but including 5. Here we have it on a number line. We got our -4 at the bottom, a not colored in circle to show that it doesn't include it, approaches -4 but doesn't include it, though it does include 5. Here's our interval notation. We have a round bracket to show that it does not reach -4, and a square bracket to show that it does reach +5. And our set notation is y such that it is greater than -4 and less than or equal to 5, and that y is an element of all real numbers. Okay, a lot of description in the beginning. Let's play around with it a little bit. So describe the set of numbers indicated by each number line using interval and set notation. So we're going to be using this one right here and this one right here. So let's start with our interval notation. Let's kind of look what's going on. Looks like we have, I'm going to use domain for this. So I'm going to claim these are x values. And so let's see, we have our lower end, -4, does not reach the -4. We have a not colored in circle. So I'm using this maybe I'll write this down. This bracket equals does not reach. And this square bracket equals, let's say maybe includes, is that a better word? So this one does not reach -4, and it includes 3. Okay. And as set notation, let's say we use our squiggly line. We have x is such that it is, let's see, -4 is our lower end. It's greater than, x is greater than that, but does not include that. And it is less than or equal to 3. And x includes all real numbers, or is an element of all real numbers. Okay, we'll practice again. Let's try this again. Just interval and set notation. Okay. Let's do the next one. Looks like our x's, I'm going to do domain. I could do range, but let's do domain. Looks like we have our lower end is 3. And looks like, so, and it does include that. So let's use our square bracket. And when's our upper end though? Seems to go on and on forever. And how we show that is with this infinity symbol like that, an 8 on its side. And you always, always, always use the round bracket for infinity, because if you think, you don't actually ever achieve affinity. You can't reach affinity. It goes on and on forever. So it's not really something that you can reach. It's not something you can achieve. So you never quite reach infinity. So that's how you would show that it, so that our x, the lower end is 3. It includes 3. We have the colored in dot. And the kind of upper end is infinity, and we're never going to reach that. And then we can show this in set notation with our little squiggly brackets. That means set. x is such that it has our 3, it's going to be greater than or equal to 3, and x is an element of all real numbers, like that. Okay, let's do our next one. Here we have a bit of a gap. So how do we deal with this? We basically deal with this with a bit of an OR situation. So here we have that we start at -1 and we go on and on forever. So we want to here's also, we show it as negative infinity, and it goes on and on forever. And our upper end is -1. And we have a colored in dot, so it includes that -1. Or we can have our lower end. It does not include the 4. And it goes, our upper end is infinity, goes on and on forever, and does not include that. Okay, so our, let's call this one our range. Why not? Is that it's going to go on and on forever to negative infinity, and it doesn't include that because we can't actually reach it. And the upper end is -1. We do include that because we have a colored in dot. Or it can be 4, but it doesn't quite reach the 4, so we use a round bracket. And the upper end is positive infinity, but it's not going to reach that, so we use the round bracket as well. And now we can show this as we use our squiggly bracket. Y is such that it is y is less than or equal to -1, or y is, let's say, greater than 4, and y is an element of all real numbers. Squiggly bracket. Hello, everybody. I'm coming back to it hours later, but here we are. Number 3, give the domain and range of each using a number line, interval notation, and set notation. I think I'm going to take out number line. I think we know how to do that. Maybe I'll give you a quick number line at the end. But for each of these, we need to give the domain and range. So domain, let's start with, and we're going to do range after. So the domain, all of the possible x values. Well, let's have a look. This has a little arrow that's going in each direction. Let me zoom in a little bit. A little arrow that's going in each direction. So this goes on and on and on. So it's going to end up covering every x, and every positive x, every negative x, every x, on and on and on. So in our interval notation, we're going to have, it's going to never quite reach negative infinity, and it would go all the way up to, but never quite reaching positive infinity. So it's all x values. And in set notation, we would use the squiggly line. The set includes x is all real numbers. That's it. That our x is going to include all real numbers, all possibilities. And for our range, going to be, pretty much the same thing. These are all of our y's. These are all of our x's that we have as well. It's going on and on and on in each direction. It's going down, all through all of the y's forever. We're also going to have a negative infinity and a positive infinity. And then we'll also have our little squiggly line that y is an element of all real numbers, just like that. As a maybe for the domain, I'll show you what a number line could look like. A number line could look like this. We got 0, 1, 2, 3, -1, -2, -3, and we could have show that a line goes on and on forever in every direction, something like that. Okay, let's look at our other one. We have a parabola here. The domain, so our x's looks like it's going to continue to open up in a kind of U shape, and it looks like we're going to cover every single x. We go on and on in each direction forever. So it looks like we're going to include every x. So we're going to go to negative infinity and to positive infinity. My infinity symbols are not the best. Maybe after this unit I'll have improved. And our set notation is also the same as our last one, a squiggly line, that x is going to be an element of all real numbers. But our range will be a little bit different, at least for this one. This is our y's, these are our x's. The range looks like we're going to start here at -1 and go on from that. So our lowest point is going to include -1 and go up to positive infinity. But it won't ever reach positive infinity, so we use the round bracket. And when we do our set notation, we can do our squiggly line. Y is an element of, it's going to be y is, let's say, greater than or equal to -1. And y is an element of all real numbers, like that. And if you wanted to show this one on a number line, we could do, let's do the range just for fun. Let's do 0, -1, -2, 1, 2, 3. I would circle in this -1 and show that we're going on in that direction forever. Okay, let's try number 4. And here is where the list part comes in. Here's where we need to do a list. And this is when our data is discrete. Okay, so this is not continuous. This is only when our data is discrete. So here, we're not connected between these dots. We have discrete and distinct dots. And so what we have to do for our domain and range with these ones is show them as a list. So this is going to include, use a squiggly bracket. Looks like we have for our x's a -2. We have 2 -2s, but you only have to show one of them. So we got a -2. Looks like we have a -1. So you do comma, -1. Looks like we also have a +1, and we have a +2 in the squiggly bracket. And our range looks like the bottom one. This is our first one here. Use our squiggly line. I forget of these squiggly lines either. -1. Looks like we have right there a +1. And we have 3 of those ones at 2. We just have to show it once. So it looks like that. So this, when you do a list like this, it's to show discrete data. For B, let's do our domain and range again. And range. Let's do, so the possible values for X will be 7, 5, 3, 1. And our possible values for the Y's are 3, 2, 1, 0. Wow, I think my squiggly lines are getting worse. Anyways, you get the picture. And for our last one, let's do domain and range again. Remember, our ordered pairs are always shown as x, y, x, y, x, y. So our domain, let me do nice squiggly ones. Oh, it's not bad. Are going to be 10, 8, 6, 4, 2. And our range is going to be the second number, 5, 4, 3, 2, 1. Like that. Okay, thank you so much. I'll let you know what textbook questions I'd like you to do.